Okay, so we'll be starting exercise 7.1, right? The distance formula. So the first question, find a distance between 2, 3, and 4. So those are 2 points. So we're going to take it to be P and Q. All right. So from here, let's write down first x1, y1, x2, and y2. So this is your x1, y1, x2, y2. All right, so pretty simple. So this is just a rough diagram here, right? Not up to scale or anything like that. So let's find distance of PQ. So we just have to put the distance formula, x2 minus root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 is how much? X2 is 4, so we have put here, and then x1 is 2, so once again here, right? Then y2 is 1, and then y1 is 3, right? Then here 4 minus 2, we're going to get 2, but remember the square is here. Okay, so square again. 1 minus 3, or when we subtract, our answer will be minus 2, right? And remember the square again. Okay, then 2 2s are 4, right? Then minus into minus will become plus, then 2 2s are 4 again. So we're going to have root 8. Or if we try to find the factors, then 2 4s are 8, then 2 2, and then 2 1 time, right? So 2 squares here, that is why 1 2 is outside, and then this is the 2 that is under the root. Okay, so the distance of PQ equals to root 2. So let's try one more. Minus 5 7, and then minus 1 3, right? Once again, we'll take it to P and Q, so you can already see here, and put the value again. So this is x1, y1, x2, y2. All right, now distance of PQ, write the distance formula again, and we'll just start putting the values again. So x2 is what? Minus 1, and then x1 is minus 5. That's why you can see here that this minus is there because of the formula, but if you look at x1, it is minus 5, right? So under bracket minus 5. All right, next let's go to y2. Y2 is 3, so here it is, and then y1 is 7. Okay, 7. All right, now let's finish whatever is inside the bracket first. All right, so minus into minus plus, that's why you can see minus 1 plus 5. And here 3 minus 4, once again minus is greater, so when we subtract, it will be minus 4. Then again here minus 1 plus 5, so obviously you can see that plus is greater, right? So this will be 4 square. Then just writing as it is, then 4 4s are 16, minus into minus plus, 4 4s are 16. We're going to have a 32. If we try to find the factors, then we're going to have what? 4 into 4 into 2, right? So 1 4 will come out, and then our distance of PQ will be 4 root 2. Okay, so now the next question, determine if the points 1 5 2 3 and minus 2 minus 11 are collinear. Okay, so we'll take it to be A, B, and C. So these 3 points will be collinear if they lie on the same line. Okay, so in order to prove whether they lie on the same line or not, can we do like this? AB plus BC should give me the whole length, right? If they lie on the same plane, if they lie on the same line or in the same plane, then it should be valid. Okay, AB plus BC equals AC. So these are the other two conditions again, but here we'll only be trying to do the first one. Okay, so if AB plus BC equals AC, then we'll say that they are collinear, that the points lie on the same plane or line. Okay, but like I said, we'll only be doing for the first case. Okay, all right, so the first case, first we have to find is what? AB, right? So I've AB here, then from here x1 y1 x2 y2. So I'm just writing down the value. Okay, so distance of AB plus distance of BC should be equal to distance of AC. If we can prove that they lie on the same line or plane. Okay, so distance of AB, x2 is 2, so I've written here, and then x1 is 1. Right, then y2 is 3, then y1 is 5. All right, then 2 minus 1 1, 3 minus 5 minus 2. 1 square is 1, then minus 2 minus plus 2 2s are 4. So we're getting distance of AB to be equal to root over 5. Now let's try with BC again. Okay, so once again I've written BC for us here, x1 y1 x2 y2. So we've written a value. Now let's find distance of BC again. So x2 is what? Minus 2, so we've written, then x1 is 2, right? Then y2 is minus 11, and then y1 is 3. Then they're both minus, so we have to add them, but the sign will be minus. Minus 2 we'll get minus 4. Same thing again here, minus 14. So when you add then minus into minus plus 4 4s are 16, minus into minus plus 14 square 196. If we add these two, we're going to get root over 212. Now let's try the last one again. So now AC is the last, right? So distance, so x1 y1 x2 y2. So we've written here, and let's find distance of AC again. x2 is minus 2, x1 is 1. All right, then y2 is minus 11, we've written, and then y1 is 5. All right, Minus 2 minus 1 will give us minus 3. Minus 11 minus 15 will give us minus 16. Then minus into minus plus 3 3 is a 9. Minus into minus plus 16 square is 256. So when we add this, we're going to get 265. So now if you look here, we got AB is root 5, then BC is root over 212, and AC is 265. Can you see that here AB plus BC is not equal to AC? It will never be, okay? So we can say now, since they're not equal, the points are not collinear. And also remember, you can try for these two again, okay? BC plus AC equals AB, check. And even AB plus AC, is it equal to BC or not? All right, you can check.